And next we are going to dive into the world of components. In previous two videos we started our new bike lure. We worked with the profile tab to create side profile, top profile, and then moved from left to right into the bend tab and gave this lure a slight curvature. And now that I'm looking closer to the lure, I'm seeing a small inconsistency over here. I do not like how this curvature makes an angle over here. So I'm going just slightly back, and now I'm satisfied. I'm saving my changes. I can see this asterisk mark that I have unsaved changes, and when that disappears I know that it's safe to move forward. And we move right to the components tab. We can see that our tools are changing here on the left hand side, and when we want to add components we click this button over here. It opens component library where we have several categories. We have swimming lips, the same ones that we have also available in our webshop, plus one scalable size or scalable model. Then we have balanced tail plates for ice swimming jigs, both straight ones. This is the format that we deliver them, and then we have bent ones. So in the middle there is this kind of a carving that allows you to bend it into an angle. That's the typical way how you want to insert that later on. We have figure 8 forms, very typical for injection molded lures, but also quite handy if you are planning to manufacture your prototypes with 3D prints. Then we have weight balls, metric sizes, but you can also scale them into some size that you wish. And also to be noted is that you can also do cavities to your lure with these balls, so you can just make a round cavity and you don't need to insert that exact size weight, of course, into the final lure. Then we have miscellaneous components in cavities and fill blocks. We have eye cavities on certain size and very common scalable eye cavity. So if you have 3D molded eyes or sticker eyes, you might want to have this kind of a cavity so it's a little bit more durable. It's not wearing out or fish cannot strike it away from your lure so easily. And then we have different sizes of holes. For example, if you are planning to insert a single hook to your ice fishing jig and you just want to make a hole where you can put that hook shank, these are the components that you could use for that. And then you have a wall, so if you want to have like extra strength for your lure, or you want to make some kind of chamber for your rattle balls or things like that, you can do it with this wall, and you can scale it into the dimensions that you like to have it. Then we also have tails. So if you are planning to do some soft baits, you can add some simple shad tails or crab tails or this type of models that we have here. Each one of these is scalable, so you can insert them and put them into the right size. And then we have also a set of fish fins. So these are modeled from roach, and hopefully in the future we can also add another species. So this is just the start that we have over here. And let's start from eye cavities. That's very typical to have on a lure. So I'll select this eye cavity, scalable. It's highlighted just slightly, and then I click add component. And as default, the new component is inserted into coordinate point 0.0.0. And now I can position my cursor to the center, to this control node, click my index finger down, keep it down and drag the component to the position I want it to be. I start from the side profile. And here on the top view I can see that it's also in the center line. That's not the position I want the eye to be, so I will drag that outwards. And you can see also in the coordinates how the values are changing. So these coordinates are starting from this point, from the center of the lure or so. So I can do this kind of a very fine tuning either by zooming in and doing more subtle changes, or then I can just type in here coordinate values that I want. And you can see that when I've selected the component, it's telling here that which of the component is selected. I can also rotate the component. So this circle over here, you can see that there is this kind of a helper balloon or orange dot when I'm positioning my mouse cursor there. I'm now clicking with my index finger and then I'm dragging so it rotates the component nicely. And here in this case I'm quite happy that where the component is, I'm just aligning it in the top profile to match the curvature of the lure. Note that eye cavity has a draft angle. So if you're doing a hard resin bait, you want this draft angle to still leave a shape that you can release from your mold. If you're doing silicone bait, some soft bait, this is not so important. You might have a negative draft angle in your molds, but depending how you manufacture them, you might end up into a different type of challenges. And here in the cross section, I'm also seeing the same component, and I can rotate it here as well. So if you have a really hard position, you might need to do this several times. I'm actually quite happy to the size of this component, but just for practice reasons I'm scaling it now. And note that in eye cavities, this is now 15 millimeters wide, 15 millimeters tall and 5 millimeters deep eye cavity. But this is not the exact eye size that you can insert to this because of this draft angle. So the bottom of the eye cavity is slightly smaller. And also, if you're manufacturing prototypes from 3D prints, you need to add a little bit of tolerance, because 3D printers are keen to do this kind of holes and cavities a little bit smaller in reality than what's their nominal dimension. So let's say that I would like to insert 13 millimeter diameter eye to this cavity. I would add a little bit of tolerance, 13.8 perhaps. And you can notice that it now scaled both the height and width of the component as depth. If I would like to do elliptical one, I could uncheck this lock here, and then I could change these dimensions however I would like. So you can see that I would be able to do also a deeper eye cavity by doing it like that. But let's leave that to something relatively simple. Then with eyes, I typically do so that I center the 3D view to the middle of the eye cavity and rotate it a little bit to see that how do the edges look like. And here you can see that the bottom edge, it's much more deep than the top one. So I would need to rotate this a little bit, and this one I'm doing it in the cross-section view. So when I'm doing like this, you can see that it's now, it went a little bit too much. Eye cavities are typically components that you need to adjust quite many times to get them right. And for this lure, I don't need so deep edges over here because it's going to be hard resin. I'm pretty satisfied with it, and also I'm watching to these draft angles. This is quite there on the edge, but let's rotate it just slightly, so I'm getting a little bit of release angle over here. Here I have release, here I have release. I think I'm happy with it. And the beauty of the LureBuilder, I now position this component to the left hand side. I click this button, mirror component, and tada, we have a right side eye cavity now exactly in the same position. They are symmetrical, so you don't need to manually measure that to your prototype. And next I'm going to add my line and hook attachment points. I go to the component library, add component, I go to the figure 8 category, and I know by experience that these are going from smaller to larger ones. I'm testing figure 8-8 how that would look like, and it's looking quite decent size. Perhaps even that larger one could fit to this bike lure, so I just keep this selected. I remove component. I go again to the figure 8 library, select figure 8-9, and yes, it's looking a little bit better for this lure. So I'm first dragging that into the position in the side view, and here you need to consider that what kind of coating you're trying to use. So if you're using thick epoxy, it's not too much to have a little bit of space like here, but I'm using hard resin. I don't need so much of epoxy, or if I'm doing 3D printed prototype, that could also be one alternative. I'll position it like this, and I'll leave it into this angle. Then I'm adding another one of the same size, and this one I'm rotating, taking it from this circle here and dragging it into the position. And as you can see, these components, they are kept in the center line. I don't need to worry about that, and I'm just zooming in to get approximately same clearance here between the loop and the lure surface. And with belly hook hanger, I'm keeping this kind of a principle that I want it to be quite perpendicular to the lure surface. That's just my personal preference. And I'm adding also third one here to the tail of the lure. In principle, in figure 8 forms, one of the sides is open, but now that we are just making these cavities and positions, I don't pay attention to how they are rotated. Now that I'm positioning this tail hook hanger, I'm seeing that I'm getting quite thin edges over here. This perhaps could be still manufacturable, but just to make it sure, I go back to the profile tab and I make this tail just a little bit wider, and I'm checking that how that would look like in the final lure. I'm much happier with that, and you can see when I change between profile and component tab that this component tab has now the end result of bending also applied or showing in our view. Good. We have now our A cavities, which are symmetric on both sides. We have our hook hangers and we have our line attachment loop. I'm pretty happy, so I'm saving this. And these components are something that I can easily remove afterwards, so I don't need to save this as another copy. As I'm doing this, I could even rename this to be bent with components. So just trying to give all the time describing name to my lure I'm working with. Next I will add swimming lip for my lure. I click add component and go into the lips category, and here you can see our standard models. These are coded so that first two letters tell some characteristic of the lip. DD is deep diving, or typically used in deep diving lures. LA is ladder lip, RO is round, etc. SA for saddle. And dimensions are tenths of millimeter. So DD210 is 21 millimeters wide lip, and 41 millimeters long on its maximum effective length. Aero 200 is 20 millimeters wide lip, and so on. So you get a little bit of idea how it goes. And let's try with a relatively large lip. Let's put this ST200 290 and see how it looks like. I select it and add component, and again it's inserted into the origo, and I drag it into approximately right position inside profile first, and then rotate it into some angle. And here I'm seeing that this might be a little bit too small lip for this lure. Well, to shallow diver it could go quite well. So next I'm checking that when I have positioned the lip, that it doesn't overlap with any physical component, and it doesn't break in or break out from the eye cavities. So I'm keeping this away from my figure 8, having it in 61-degree angle. Let's just, for engineering sake, give also measurements here, so you can set up some particular angle by typing it into these fields. I'm not touching these other ones because typically I want my lips to be perfectly aligned along the center line. And when I'm happy, I can click also Save Lure again. The next logical step would be to add some weight for this lure, and let's take a look to the properties of the lure. So I just saved it and I click this Properties tab. I can see that the length is still at 160 millimeters, and it doesn't change actually in LureBuilder from what we set in the beginning. I can see surface area, very miscellaneous information, but next two figures, they interest me quite a lot. So this hull volume, 63.64 cubic centimeters, it's telling me that this lure approximately replaces this amount of water. So in fresh water, 1 cubic centimeter of water, it weighs 1 gram. And if I would make 63.64 gram weighting lure, it would be neutral buoyancy for the lure body. And this is a little bit like an estimation. I don't have hooks here, I don't have these figure 8s, I don't have other components included in this calculation. So please take this as a rough value. But this already gives me some kind of an idea. I plan to have 160 millimeter long pike lure and 64 grams, that would be neutral buoyancy. Do I want to have floating lure? Do I want to have sinking lure? Whatever I would plan to have, this gives me some kind of an idea. And let's say that I would like to get floating lure, so it would tell me that all my weights that I'm putting into the lure, it cannot exceed this 63 point something in grams. And to be on the safe side, I could target that this could be, for example, 50 gram weighting lure. If you're doing sinking ones, then it's more important, and especially that neutral buoyancy, you can play with this value. So how do I know then that how much of weight balls, for example, I should put there? I would select perhaps the hooks that I want to use in this lure, split rings, I would weight them, and then I would look to this value, solid volume. So 34.85 cubic centimeters. That would be the amount of plastic or whatever material that would be consumed in this lure. So you remember that we set a wall thickness for this lure. With that wall thickness, we would get this much of material into our lure body. And if I know the nominal weight of my material, I could easily calculate that how much this weight would actually mean. And I'm planning to make this lure prototype from polylactic acid material, and I know that its nominal weight is 1.17 perhaps for that brand that I'm most often using. So I would then know that I already have 40.7 grams, 40.8 grams of weight from my 3D printed parts. So it would give me approximately 10 grams to play to my target weight. And with that information, we have here also in our support section some weights of typical steel balls. So let's say that from that 10 grams that I could add, I would reserve 5 grams approximately to the hooks, and it would give me possibility to insert perhaps 2 9mm balls, or having a little bit more cavities. I'm going back to the LureBuilder and going into the components section, adding component, weight balls, and here I would have ready 9mm steel ball, but I like to give a little bit more tolerance now for this, so I'm putting that again into, let's say, 10mm. That would be a better figure, and I had lock on, so it scaled it evenly in all 3 axes. And then the position of the weights, that you need to play with your experience, and I'm just trying to keep enough material here so I'm not putting them straight to the edge so they would stick out from the lure. And I'm adding a few extra ones also. So 2 was the amount that I'm needing for this lure, and I don't know that which combination, which weight actually gives me best swimming motion, so I'm putting 1 extra here. And some tips for this: avoid locating these weight balls close to your other components, so especially if they are too close to figure 8 forms, they will create a little bit challenge for the computer when the final lure geometry is calculated. I could perhaps add one still. And if you over exaggerate, put too much of components, then this computing and calculation will fail in the end. That's a bit rare, but can happen. But I'm pretty happy with this, so I'm saving the lure again. Next I will add some surface details. I go to natural fish fins, and let's add pectoral fin of a roach, and you can see here that it's brought quite small into the project. So let me drag that first visible also in the 3D view and roughly into its position. And for the size, let's try 25mm. It's quite decent. And then I click this point with my index finger to center the view, and then with my middle finger I'm rotating it, and you can see that it's now a bit out from the lure body. We can see it also here in the cross-section view. I'm keeping that in the position in the side view, but now first working with cross-section, turning that into the angle that this lure surface would demand. Click with an index finger and rotate that a little bit. Then I'm zooming in the top view, and I'm bringing this a little bit closer to the surface. So first getting that front edge of the fin being quite nicely in shape or in the position. I'm not happy with the back side, so now I am rotating it in the top view so that back goes a little bit deeper into the lure body. And here again, I'm looking to the draft angles. I could end up into small troubles here on this section if I'm working with rigid material mold. But for this I'm planning to have silicone mold, even though that I'm casting with hard resin. I'm quite happy with this. Perhaps it could be just slightly deeper still. Let's have it there, and now we are missing one on each side, so I'm just keeping this selected and click mirror component, and when I rotate we can see that it appeared also to the left hand side. That's pretty much it. I will describe these more miscellaneous components in the library, cavities, tails, etc. in some other video. One piece of warning: if you're adding tails, if you're adding swim lips, they do not show in the lure length, and they do not show in the lure properties in the volume. So you might need to ask our advice if you're doing very big tails and you want to have exact volume and weight information in place. Thanks for watching. Next video will be our carving tab.